proceed on. Good afternoon. Welcome back. So I will go through a set of slides similar to what we did last year, but the emphasis this time round will be on the actual practicals which we are going to do from training material in Nextflow. So they do have a whole bunch of materials that can allow us to get a feel of how Nextflow works. So an overview of what we will look at is we'll be looking at specifically what a workflow and what are some of the workflow management systems, why you should use a workflow management system, and then specifically dig into understand what Nextflow is, what are the main features of Nextflow, what are the main components of a Nextflow script, and how to run a Nextflow script. So the objectives would be to understand workflow management systems, the benefits of using a workflow management system, explain the benefits of using Nextflow as part of your bioinformatics workflow, explain the components of a Nextflow script, and finally how to run a Nextflow script. Yeah, so to begin us off is But anyway, we'll proceed on. So when we talk about workflows, what we have in mind is a depiction of you obtain your data, you want to analyze that data, and basically analyzing that data will constitute a series or a sequence of tasks, including gathering, cleaning, and processing the data. So this sequence of tasks are called a workflow or a pipeline. So an example of a workflow indicated in this diagram are two NFO pipelines for detecting variants, either from germline or somatic. So when you talk about workflows, it's just about the stitching in of the different steps or processes that you are going to undertake in order to arrive at a final result. So basically that's what workflow is. So the different steps could constitute a Python processing script, or a script written in Bash or R, whichever language. So stitching in those steps together constitute what is called a workflow. Now we have different workflow management systems. For instance, we have SnakeMake, we have Galaxy, which is web-based, and Nextflow, which have been developed specifically for computational data analysis workflows in the fields of bioinformatics, physics, chemistry, and so on and so forth. Now there are a couple of features that are common to these workflows, including their development, monitoring, execution, and sharing. So workflow management systems have what we call the runtime management. So what this means is that the management of a program execution on the operating system and splitting of the tasks and data to run at the same time in a process which constitutes to what you call parallelization. Or in other words, how do you simultaneously run a process concurrently with another one? So they have a way of managing how tasks or processes are run when you execute a specific job. Another feature of workflow management systems is that they have a way of how to manage the software. So mostly this is done using containerization, using Docker or Singularity, and also using package management or environment management systems such as Conda. The other feature of workflow management systems is that they are portable and interoperable. So that means workflows written in one system can be run on another system. I could have a workflow running on my computer, and I need to share it with a collaborator elsewhere. Then I can easily port my workflow to my collaborator's computer for him or her to be able to run the same workflow. Workflow management systems also enables reproducibility, because when you use software management systems, you are able to have the same set of versions of software or tools that you're running in that workflow, and be able to use the same workflow with those particular software from another computer or machine. Now, the other common feature of workflow management systems, especially this I think has been implemented in Nextflow, is reentrancy. So there are continuous checkpoints which allow the workflows to resume a job if it's cut short by probably a power outage, or maybe there was something wrong in your workflow. You are able to resume from where it had stopped from. Now, we can make a distinction between the different workflows, and in this regard, I will highlight the major differences between Nextflow and SnakeMake. So SnakeMake is built on top of Python programming language. On the other hand, Nextflow uses Groovy. I think this is more Java programming. In SnakeMake, in terms of data, everything is a file. But when it comes to Nextflow, you can use both files and values. When it comes to execution, SnakeMake works in the working directory, while in Nextflow, each job has its own directory. So the philosophy of SnakeMake is pull, and that of Nextflow is push. You can perform dry runs in SnakeMake. On the other hand, that's not a common feature for Nextflow. You can also be able to do some version control in terms of tracking the code changes in Nextflow, while SnakeMake does not support that. So in terms of the scripting language, as we've said, Nextflow is built on Groovy. However, it uses a domain-specific language, also called DSL, and this has changed to a higher version, DSL2, that is more robust and handling the different use cases that Nextflow pipelines can undertake. So just like SQL or awk, it's specific to that particular domain, which is Nextflow. Okay. So the approach of having a simple DSL built on top of a more powerful general-purpose programming language like Groovy makes Nextflow very flexible. So the Nextflow syntax can handle most workflow use cases with ease, and it can also be able to handle corner cases which may be difficult to implement using DSL. As I had mentioned, there's an upgrade of this domain-specific language used in Nextflow. So nowadays, they use DSL2, which allows us to have what you call modularity on modules, whereby you can reuse a module several times, just like how you import libraries or packages in Python or R. You can be able to reuse modules and import them, use them in your workflow several times. The other advantage with DSL2 is that it has got improved data flow manipulation as compared to DSL1, which was the predecessor. So to invoke this in a workflow, you would just write a simple statement at the beginning of your Nextflow script, nextflow.enable.dsl is equal to 2. Yeah, so what are some of the features of Nextflow script? So Nextflow workflows have 3 main parts. You have the processes, you have the channels, and you have the workflows. So processes describe a task that is being undertaken or being run by a specific tool or job. So the process script can be written in any language. Excuse me. You can write the process using Python, using Bash, using any scripting language that you're familiar with. One thing to note is that the only data that can be passed between processes occurs via what we call asynchronous queues or channels. And processes define inputs and outputs for a task. Okay. So to manipulate the flow of data, you use channels. You have to define your input channel, and Nextflow, once it executes a job, it will output another channel. So your input and output forms the channels. So a simple depiction of how that works, you have a channel. So in this representation here, you have 3 data files. These are raw FASTQ files. So they act as your input. So you have an input channels containing your samples, and you're taking them through a process of quality control using FastQC. And each of these channels is going to emit an output channel. Each of these files is going to be emitted as an output channel. And this can be further collected using a method in Nextflow and subjected to another tool. So you can see clearly here that we expect an input channel, the process, and an output channel. So in terms of workflow execution, while the process defines what command or script has to be executed, the executor determines how a script is run in the target system. So by the executor here, we have various executors that Nextflow implements. You can run the machine locally on your computer, and the executor could be a Conda environment. It could be a Docker, using Docker container, or you can run your script on a high-performance computing cluster, where now you make use of resources such as job schedulers, such as Slurm, or which is the other one, or yeah, which other, or Talk, which other scheduler? Yeah, yeah. So Nextflow is able to use that to run your processes using those resources that are available in your environment. So this is a depiction of how a process definition block looks like. So we are invoking this statement to show that we want to use DSL2. So it begins by the keyword a process, and then you give it a name. There could be directives here that you indicate, but the main components would be the input. So you require some inputs in form of channels or values. You expect an output, still a channel, and then you can put conditionals. I mean, when something happens, or if something happens, then do this. And then you have this script feature, where now you run the actual process or the command that you want your script to do. Further, this can be shown here. You can just have a process that does not take any input channel, but you explicitly specify the inputs by using the path to your file. Here you're processing a BAM file, so you're sorting it, and then you're going to index it and then compute some statistics on the resulting BAM file. Now, to run a script, you can either run a script by explicitly writing the script under the script section of your block. You can write a Python script there, or you can write a Python script elsewhere and call it as a file to be able to run whatever you want the script to do. How you invoke the workflow is, once you have written your process, you just type the keyword workflow and then enclose that in these curly braces in the name of your process. So I will skip this part because we did it last time and focus more on channels and operators. So as I say, channels are synchronous, meaning that the output from a set of processes will not be necessarily produced in the order they are given as inputs. So the first element is, it follows the FIFO, I mean first in, first out. So that's how channels in Nextflow work. So channels only send data in one direction, from a producer, which is a process, to a consumer, which is another process.
Yeah. Sorry, for the previous example, the slum, the subject. Yes, so for this, how many, I'm sorry I might be naive on this, how many inputs are in there? Is it 3 or that's just one input?
This is one input. It's just a BAM file. You give the path to the BAM file. But remember, I said you can, most Nextflow scripts will have an input channel, will have an output channel, and will have a segment for the script. So how you abstract the input is by either using channels. So if you have a directory having a list of BAM files, then you can find all the files that probably end with .bam and give it as a channel. But in this case, you're only referring to one specific file. Yeah. Yeah, back to here. So there we have different types of channels in Nextflow. We have queue and value channels. So the queue channels is a type of channel in which data is used up to make an input for a process, and they can be created in two ways. So they can be created as an output of a process, or they can be explicitly specified using channel factory methods that Nextflow uses. So you can use a method such as channel of or channel dot from path if you want fast queue files that are paired end. You can use either of these. We can also have value channels. These are mostly single values or singleton, where you explicitly state that this particular variable should be used in all instances in your Nextflow pipeline. So as I said, factory channels are methods in Nextflow. So you can have a channel of, if you can have channel from list, from path, from file pairs, or from S arrays. So this will expect some accessions that you can use to easily query the SRA through API invocations to get those files. Here are some of the examples. We have here a channel of, this is a value channel, so it's just one variable given as the input. We can have multiple values given in form of a list, and this will result into this. We can have also channel off. This will not output a list as opposed to channel value. Here you see this is a list, the other one is not a list. So you have to make a distinction on when and how to apply these different channels. So you have a channel of integers here, you are outputting them, and you also want to combine with another channel of a single string. So to combine them, you can use a mix, and that will create like an elongated channel with all the inputs. And if you want to collect them, then this will create a list of all those channels. Yeah, you can also use a channel from path to specify you want only the forward and reverse reads FASTQ files, and this will output this kind of a channel. So it will group your samples according to the names while taking into consideration the either being forward or reverse reads. Yeah. You can create a channel from file pairs and specify that you only need 2 files or 2 samples in a given directory. And this will be determined by an this will be sorted alphabetically. So in this directory where you have your row reads either forward or reverse, but you only want two samples, so it will only depict this and this other one. You can also perform some filtering. I mean, Nextflow, as we said, is a scripting language which allows you to filter your channels. So, for instance, you have this channel, and you only want to get values that are integers or numbers. Then you can filter and specify that accordingly, and this will give you what you're interested in. You can further transform your channels by replacing some specific strings or characters in those channels. For instance, in this case, you want to replace all the instances of CHR, and this should correspond to the integers that remain. I think in this first value of this channel should have been CHR1. So there are lots of manipulations that you can do with Nextflow as a scripting language. So this you shall see when we get to the actual training, the actual tutorials. But another thing to mention is that Nextflow hosts quite a number of community or project-specific workflows which we can make use of. So this is available as NF-core pipelines. Nextflow also has what they call a Nextflow tower, which allows you to execute your pipelines in a very robust way to improve productivity, to reduce costs, to remove complexity, and also to simplify compliance. Yeah, so I think the other good thing about Nextflow is that it allows you to run your pipelines on different platforms. You can run it on cloud, you can run it on your HPC using Slurm, you can run it on clusters, on-premise clusters. If you have an HPC in your institution, you can easily run this pipeline. It also allows you to containerize your environment. It implements Docker, it implements Amazon ECR. It also allows you to implement workflows using Conda or Singularity. So you can, of course, seamlessly track changes using source code management platforms such as GitHub, GitLab, or Bitbucket. And Nextflow is being used by a number of clients as part of their analysis pipelines. So I think with that, I think it has given us a recap of what we did last year. So this time around, probably we can do more hands-on. And for this work, I think we can make use of the tutorials that the NF Core team have availed to get us up running on this Nextflow thing. Yeah, last year it was not possible because we didn't have enough time, but yeah, we have this afternoon and probably tomorrow to test on the knowledge that we have, this introductory knowledge we have on Nextflow to see how we can implement a simple pipeline. So it could be for beginners, normally there is a simple RNA-seq pipeline, but I think for us, we can delve a notch higher to try a different pipeline altogether. So I'll share the link once we are up there. I'm having issues with my internet, but in case you have any questions or anything you may want to ask, gladly welcome. At ILRI, we use Nextflow for some of our analysis. For instance, Kibet, and also have been using the NF-Core viral recon pipeline to perform analysis on SARS-CoV sequence data. Yeah, and they are here also to train, but also to be trained, but also to give in their insights on how they find Nextflow in general.